Hello, hello, Shagat the Known here. Welcome back to another Rust coding stream here on the 4th of January 2023, local time 1701. And last time, 1702 now. Last time, we added this layering and builder chaining and stuff to our code, which was basically a big old giant refactor. So now we have this concept of like the builder chain with two traits. We can do the traits, yeah, the initial map builder and the meta map builder. Meta map builders, oops, I'm sorry, I forgot I still had that on there. It's fine. We have the concept of the builder chain right here, with basically defining all the state that we're going to maintain throughout the course of running through this like layering process. So we have like our spawn list, a map, starting position, rooms, history, all that kind of standard stuff. We have a vector of builders, and that's how we're allowed to apply multiple builders. We have two main traits that we're working with: the initial map builder and the meta map builder. So an initial map builder is what we use to kind of seed the entire map. And then the meta map builders get applied to the different initial map builders. So the random initial builder gets us something that we have implemented that trait for, which is like the BSP, the cellular automata, drunkard's walk, maze builder, DLA, Voronoi cell builder, or prefab, or simple map. So one of those, and then the random builder will actually apply these different meta map builders to it. So we see if it has rooms, then we do a room-based spawner, room-based stairs, room-based starting position. Or if it doesn't have rooms, we do the area starting position. We call the unreachable areas, we do Voronoi-based spawning, and we calculate the most distant exit. And then we randomly do wave function collapse, and we randomly apply the fortress prefab, and we always apply vaults. So we have this kind of nicer structure. It's a little bit, you know, if we just wanted to do a single map, it's a little bit, well, I wouldn't say it's more verbose, but in terms of allowing us this flexibility, it's way better than what we had before. If you wanted to just hard code the map in and you always wanted it to be the same thing, all the work to do this was kind of meaningless. But if you want this randomness and you want to easily be able to have this nice interface, then the work was entirely worth it, even though it was a lot of work to do the refactor. So we can run it, and in like most cases, not much really changes. We're doing binary space partitioning here. No, are we? I think we are. I don't know if that was a simple map. Now we're doing a wave function collapse on it, and we're getting some goofy results. Looks like we're gonna have something that's kind of workable. Yeah, cool. All right, so enough of that. Let's get to today's session, which is going to be called Fun with Layers. So here we are, and it's a little bit shorter, at least by size of the scroll bar. We'll see what the actual lesson goes like. Now that we have a nice clean layering system, we'll take the opportunity to play with it a bit. This chapter is a collection of things you can do with layers, and we'll introduce a few new layer types. It's meant to whet your appetite to write more. The sky really is the limit. So we're going to talk about existing algorithms as meta builders. So we're going to start by adjusting some of the existing algorithms to be useful as filters. So we're going to do applying cellular automata as a meta builder. So that's cool because we can then use another map to seed our cellular automata map, which actually makes a lot of sense. When we wrote the cellular automata system, we aimed for a generic cavern builder. The algorithm is capable of quite a bit more than that. Each iteration is basically a meta builder running on the previous iteration. A simple tweak allows it to also be a meta builder that only runs a single iteration. We'll start by moving the code for a single iteration into its own function, apply iteration, All right, we'll take a look at that. So we're going to do Control Shift P. I'm going to backspace 1, and I'm going to do cellular automata. And we're going to look for this code here. Let mute new tiles. And it goes through new tiles clone to this. And we do that. Now we wait for it to get mad at me. And I say, give me the function. And there we go. Very, very, very simple refactor. Nothing else changes. We make our new tiles. We loop through every tile in the map. We count the neighbors. And depending on the conditions of the neighbors, if it's more than 4 or it's 0, it becomes a wall. Otherwise, it's a floor. That's all we do. That's our rule. And then we set the tiles, and then we take a snapshot. Very easy, right? So next, we're going to add an implementation of Meta Map Builder to the mix. So we can do the impl right up here. Although we don't have Meta Map Builder, so let's do that. So impl Meta Map Builder. Oops, I should put a comma here. Impl Meta Map Builder for Cellular Automata Builder. We're going to do this fn build map, which is like the same as always. RNG is being unused. It's not being used, rather. So we can do that to make it a little bit happier. And we pass in build data to apply iteration. So the difference here is we're only saying do one iteration, whereas before we go into this build function, and the build function actually has a lot of extra code in it. So this is what's telling us to do everything multiple times, basically, to apply iteration 15 times. Excuse me. And we also have the code here, which is seeding. Well, we don't need to seed if it's a meta map builder. We just need to iterate on the map once. That's at least how we're doing it. So all we have to really do in this case is just apply iteration. And now we've modified the map based on the same rules down here, the neighboring tiles, right? Fairly simple. The tutorial text says, see how we're calling a single iteration instead of replacing the whole map? This shows how we can apply the cellular automata rules to the map and change the resultant character quite a bit. So we're going to modify the mod back here, the map builder mod, to use this meta builder version of cellular automata now. So what we're going to do is make a Voronoi map, and then we're going to run cellular automata over the top of that. And we're going to see what that ends up looking like. So let's go ahead and give it a shot. This part should come with no surprises. It's just a Voronoi map. But what should be interesting is seeing what cells get removed and added, like so. Now, it's still a pretty quick look at the map there. You don't get to quite see it for very long. So we'll do one more, so you can take a quick look at it. Here we go. Yoink. It actually changed the map quite a bit. So that is that. Very simple, right? Not too bad. So we have their example here, and you get a longer look at what their map kind of changed into a little bit, which is cool. We have a vault of some kind in here, I believe. Very cool, right? Simple. Again, we barely did anything. We said the iteration code is going to be the same. Let's make it a function. And then in the case of the meta map builder, we already have a seeded map. So just iterate on it once, apply iteration once, boom. So now we're talking about eroding a boxy map with drunken dwarves. The drunken walk algorithm can also make a nice post-processing effect with very minimal modification. In drunkard.rs, we're going to add the following, the meta map builder. And now in this case, I am going to copy this. It's basically the same thing, except we're calling build. And we're actually ready to test it. That's the crazy thing. Because of the way the traits are defined and the way that we can implement them, it's actually exceedingly easy to do this. So it's literally the exact same call here, except we need meta map builder. It's literally the exact same call here because the way we defined our code here, we assume we have a starting map with, we basically assume that our starting map is going to already be walls everywhere, so they'll carve things out, right? But we're not actually going to be feeding it a map that's just walls everywhere. We're going to be feeding it a map that's already been generated. And so the algorithm still gets to run just like normal, but it's a much different seeded map. So this is something that maybe you would have implemented it a little bit, quote unquote, incorrectly from the start. And what I mean by that is you might have had build in here setting up the start of the map by populating it all with floors and stuff, or with walls, I mean. But you would have had to refactor that away from this at some point, and it would have probably, well, given that this was an initial map, you might not have even done it last time, but this shows that the way we implemented it from the start actually paid off here by letting us just modify any map, dig any map, right? So next, we're going to go back into mod, and we're just going to slap this in here. We're going to do an initial simple map, and we're going to do the drunkard's walk on that, and just do starting positions and stuff. Fairly standard. So let's take a look at that. There we go. It's pretty cool. I like it. It's actually a pretty interesting effect. Having, you know, been playing a lot of Dwarf Fortress lately, I can't help but think about that. How you might have rooms and you just start carving around them a little bit. Not quite like you see here, but it reminds me a little bit of how you carve rooms out of or into like existing structures and stuff. All right, so this is what we've just seen, but we look at it here. You can see it happen a couple of times. That way you get a feel for what's going on. All right. Now notice how the initial boxy design now looks a bit more natural because drunken dwarves have carved out sections of the map. Indeed. Attacking your boxy map with diffusion limited aggregation. DLA can also be modified to erode an existing boxy map. Simply add the meta builder trait to DLA.rs. This is going to be a very quick session at this rate, but probably not. I just noticed the scroll bar has not moved very far. We've done a lot, but the scroll bar has not moved very far. So I think we're still going to have some time here. Yeah, we'll leave allow dead. I kind of don't like it, but it's whatever. So this is the same thing. That's why I copied it. Nothing's different. Literally, we could do the same build. The only thing that's different is that if it's a meta map builder, then we know that it already had an initial map before. So we're going to do the same thing with this one, where it's going to be a simple map builder that's then going to have the DLA ran across it. Oh, but we also wanted a new function in here as well. My bad. So this is just like another constructor that was added, heavy erosion. So it's, again, it's another constructor essentially. It just boxes up a new one and it walks inwards with a brush size of 2 with no symmetry and 0.35 floor percent. I'm copying that because it's not anything new that we haven't seen before. So now we can actually call this heavy erosion one. And let's get a look at it. So this one is still pretty slow. I would like to make some changes for that. But the cool thing that's happening here is basically it's picking a spot and then walking towards the center of the map from it. But we're getting this idea, it does look like the tunnels are kind of eroding because it ends up kind of digging in from the outside of the tunnels, right? So if we take another look at DLA, if I remember correctly, we remember the last tile. Yeah, previous X and previous Y. And if the tile is a floor, that's cool. We remember that. And then I think once we hit excuse me, if it's a wall, we remember that once we hit a floor, this will be on walk inwards. Yeah, on walk inwards. While it's a wall, we keep remembering the previous. And then once we actually hit a floor, we paint in the previous, we turn it into a wall, right? So the idea is if we pull another one of those maps up and take a quick look at it, if we start here on these walls, nothing gets changed until we actually hit a floor. And in the previous tile we were on changes. So that's why the outsides of the rooms are getting kind of eaten at a little bit. And that's why we can think of it almost like a little bit of erosion or something. Like our tunnels are breaking down or something over time. It's not 100% perfect, but it's a little bit different and interesting compared to some of the stuff that we had before. It's a way to combine two algorithms to get something very different with very little effort, as we've seen. And it makes some of this feel a lot more dynamic. Like this room on the bottom left here is pretty cool. But like almost every room just got touched with that. And they're a little more organic feeling, right? So we take a look at theirs. And there we have it. Now, see our scroll bars only moved about a fifth of the way through. Some new meta builders. There's also plenty of scope to write new map filters. We'll explore a few of the more interesting ones in this section. Pretty much anything you might use as an image filter in a program like Photoshop or GIMP could be adapted for this purpose. How useful a given filter is remains an open/interesting question. So first is eroding rooms. NetHack style boxy rooms make for some very early D&D type play, but people often remark that they aren't all that visually pleasing or interesting. One way to keep the basic room style but get a more organic look is to run Drunkard's Walk inside each room. I like to call this exploding the room, because it looks a bit like you set off dynamite in each room. So in map builders, make a new file, room exploder. I'm going to guess that we're still probably going to do the floor percent. I might be wrong, but the way that I would initially think about this is maybe still doing a floor percentage, but making it based on the room itself. If we know the size of the room, then because it's a rectangle, then we know, well, I don't know if floor percentage would make as much sense. Maybe I'm going down the wrong track. You have to know when to stop. That's what I'm trying to say. You have to have a point where you're done digging, and that's one way to do it, where we could say the room has X amount of tiles and we want this percent more. That's the idea. That's my guess on one way we could do it. This may be much nicer than my guess, but I've never done this before. So let's go. Let's make room exploder. We're just going to do it inside of map builders. Yeah. So new file, room roomexploder.rs. And we're going to need some boilerplate, which is going to include our uses. So just bring in paint, builder map, metamap builder, rect, symmetry, tile type, and a random number generator. We're going to make a room exploder struct, and we're going to import metamap builder for room exploder with the basic boilerplate, expecting a self.build. Simple. Room exploder, and we're going to make a new. It's going to box up a room exploder. And that's all there is to it. And we're done. That's the actual root. I'm joking, of course. Okay. So yeah, there's actually a lot going on this one. We need build. Okay, so now that we have this, we're going to say let rooms vec rect, and if let some rooms builder equal and build data dot rooms. I'm going to make some changes to this before we're done, and this is at no fault of the tutorial. There is a new feature in Rust that will make this code nicer. So I'm going to do that, but we'll write the code as it is in the tutorial first, and then I'll show you the newer way, which is nicer for something like this. And if we don't have rooms, then we panic. So all we're doing is ripping out the rooms from the rooms builder. So build data.rooms is what we're calling rooms builder, and then we're cloning that. So that's what I mean by ripping it out. And now we're going to loop over the rooms, iterate over them. I understand we're having one problem here. That's why I had to type all this, because I forgot to do the thing. We want to come back here and mod in room exploder. So now we get our completions. I've been wondering why we're not getting them, and of course that's why. Okay. So we get the center of the room. We set the number of diggers between 1 and... Okay, between -4 and 15, yeah. I think that, yeah, a 1d20 can be 1 to 20. So then 1 minus 5 would be -4. 20 minus 5 would be 15, of course. So if there are diggers, and that's done just so there is a slight chance that we don't do it to every room, because that makes the map more interesting. That would be my guess. So if the number of diggers is greater than 0, we're going to loop through however many there are. We'll get our X and Y value from the start, which was the center of the room initially. Actually, it's going to remain the center of the room. We'll set them to have a life of 20. And we'll set this did something as false. And then while they're alive, while their life is greater than 0, build data.map.xy index with the drunk x and drunk y to get us a map index. We're calling it drunk index. All right. Now, if the tile is a wall, did something becomes true? Now we're going to paint with a brush size of 1. So we're kind of just always painting, even if we're not changing anything, it seems. So it doesn't really hurt per se. And since it's a brush size of 1, it's not going to modify more than 1 tile, of course. We change the tiles to downstairs for the visualization of it. And then we stagger. The 1d4, and we have 4 different directions. I'm going to be lazy on this because it's a lot of boilerplate typing that we've done before. So I'm just going to copy that here. It is, we match on the stagger direction. If it's a 1, then if the drunk x is greater than 2, we can move it to the left by 1. So basically, this is simple, and I'm kind of reading line by line, which I shouldn't need to. So for 1, 2, 3, and 4, 1 and 2 are for the x directions, and we just check against the boundaries of the map. And that's what drunk x greater than 2, drunk x less than build data.map.width minus 2 represents. We do the same for the y values with 3 and 4. Okay, so after the match, oops, that's not, after the match, drunk life minus equal 1. Just shorten it a little bit. And if did something, we take a snapshot. And we're going to go through and just add any changes, like or modify any of the stairs back to floor. So there are other ways we can do this, by the way. We could do that. A simple for loop over a mutable iterator, and we do an if statement. We can also do this. Build data dot map dot tiles dot iter mute dot filter, and it's going to take in tile and star tile equal tile type downstairs. Yeah, it's because it's mutable. Give me a moment, I'll deal with that. And then you could do this here. So it's actually a bit longer looking, but it's pretty decent. So then in this closure, we're just gonna say like that. Yeah, no implementation for the mutable. Is it just double star? I think that's all I need. Yeah, my bad. I still had the reference, because you do get a double star when you do this. I think if you make this a ref, it actually helps a little bit. Nah. Yeah, there's sometimes some weird syntaxes with these. We could do the double star and be happy. So that's another option. It looks longer. To me, it's a little bit more readable, but that's all, personal opinion. It's like showing off the alternatives a little bit. One of the things is that we're also looking at a difference in the way it's getting formatted. So now it's very similar. And yes, the filter lines and the for each lines are longer, but it's not that bad. Same basic code though. All right, so there was something else I wanted to show, and it's not going to be as helpful here as I was thinking, just because I didn't read far enough ahead in the code right away, but there is a new construct in Rust in like 1.63 or whatever just came out a few weeks ago, called let else. So we say let sum rooms builder equal build data dot rooms else, and then we would put this panic in here, and then out here we would say rooms equal rooms builder dot clone. So in this case, in fact, yeah, we'd probably just do our let down here. In this case, it actually does make the code a little bit shorter. However, it's not as helpful as it would be in other situations. The difference between the if let and the let else statements, constructs, is that let else allows you to take this rooms builder back into the main scope rather than going into a nested scope. But what we've done here with this nested scope on the if let is we're basically just ripping something out of rooms builder to an external variable, and then we're getting out of that nested scope. What you might often see with an if let is something like this, to get something out of the nested scope, to kind of cheese something out of the nested scope a little bit, or you'll see a very long nested scope inside of that if let. So let else is a way to get around that by allowing you to keep your stuff out here. And I don't think we can actually clone it. I don't know if we can or not, because we might even be able to get rid of, we might not even have to declare this rooms. We might be able to just say rooms right here and be happy, but I don't know about that. And I'm going to go with this for now, because it's enough to satisfy things. But I'll probably test it in a few moments when we're actually running the code. So the tutorial text says, there's nothing too surprising in this code. It takes rooms list from the parent build data and then iterates each room. A random number, which can be 0, of drunkards is then run from the center of each room with a short lifespan, carving out the edges of each room. You can test it with the following random builder code. So yeah, we will test it in a few moments and actually see how that works. Because I would be curious to see if we can do the change that I was looking at, if that clone will work. Room exploder, pull that in. So we're going to do a BSP dungeon, and then we're going to explode the rooms. I really like this. I really, really like these results. It feels like some like worn down. Yeah, that's really cool. It feels like some place that's seen its share of, you know, it's had some wear and tear, right? So let's try even getting rid of this and calling this rooms and just doing a clone here. Because if I'm correct, well, we do have a ref. Yeah, if I'm correct, if we hit the none type here, we panic, but we can still do more things. Like, we could do this. And now, yeah, we can't move out of build data.rooms, but we can clone. So in fact, we went from this to this for the equivalent code. So let else, again, is a very new construct. It was November or December of last year, 2022. Just saying that because we're only a couple days into January. It was right near the end of 2022 that this construct was actually introduced into like a stable release of Rust. But it's pretty cool. It's good to see that the clone works that way, because it really cut down. It really, really cut down on the lines of code there. And to me, it, you know, if you showed let else, this syntax is definitely weird. Let some rooms equal build data.rooms.clone else, like what in the world is going on? I understand why this would be confusing to somebody who has never seen it, but if you understand the construct, very, very, very cool. This would work with other patterns as well, as far as I know. So we're using it on an option type. We can use it on a result type. We could probably even use it on destructuring something. If we wanted to take, yeah, we'll just do that. We'll make a struct, and we will do this here. We don't really care what's in it. But then can I say let point x dot dot? No, I'll say y 23, and then we could say test else panic, we failed. Yeah, so what we've actually done here, we'll be ripping out x from point. we'll be ripping out that X from point, and we should get 12 because we matched Y to 23. The points X is 12. We have it here. If I run this again, but oops, it's 24. We're looking for a Y of 24. We crashed because Y is actually 23. It doesn't match this pattern. So we actually went in here and did the panic, which is to be expected. So yeah, we can do basic, all kinds of pattern matching. I'd go ahead and say if we can do that destructuring there, we could probably just do the full pattern matching, which is cool. Good little thing to explore there. Really cool construct, really useful. We've seen a couple odd ways to use it now, but again, it's very useful. All right, so back to the tutorial so we don't waste time doing too many side things. This is what we just did, the BSP, and then we dig out these sides. Another quick and easy way to make a boxy map look less rectangular is to smooth the corners a bit. So we're going to add room corner rounding to map builders. And I won't forget to mod it, or to put it in the mod here. So what's it called again? It is room corner rounding, and then we're going to add that. And we're going to put this here and close off the impl block. So we have our basic boilerplate here. Room corner rounding, we're implementing meta map builder for it. We have our new function, and all we really need right now is a build, but we need a helper function as well. Fn build. All right, so we get our build function started, and it's going to be similar to what we just did for a bit. So they're doing the same thing before. They're doing let rooms is a vec. I'll copy it because we're going to rewrite it my way. But we have let rooms is the vec, and then we do the if let. Well, again, we're going to rewrite that so we can actually get rid of like all of this. Dot clone. Modified theirs rather than rewrote it. And there it is. Look how much shorter that is. Really cool. Again, you just got to know what you're looking at because it is not a normal syntax from a lot of languages. Never seen anything like it in most languages I've used. We're going to iterate through the rooms. Fill if corner. So this is our helper function. Let's make sure I got all these correct. So x1 plus 1, y1 plus 1, x2 and y1 plus 1, x1 plus 1 and y2, and x2 and y2. All right, so for each room, I'm curious about one thing here. So we're going to see how this goes when we get fill if corner. So let's do that. Put it above because we can. And it doesn't return anything, so we can get rid of that. And this takes a mutable reference to self. It takes X as an I32, Y as an I32, and build data, the mutable reference to builder map. We get our width and height from the map. Get an index from that. And start this value neighbor walls at 0. And then if X is greater than 0 and map tiles index -1 is a wall, then neighbor walls plus equal 1. So we're using the map indexing to check each of the 4 neighbors. We've done this before. We got to remember that the Y directions are the strange ones because of the way we're using a 1D array, a 1D vector to represent a 2D map. So it's index minus W as usize. And if that's a wall, then we do neighbor walls again. Plus equal 1. If X is less than W minus 2, we do that. If Y is less than H minus 2 and build data.map.tiles index plus W as usize equals tile type wall. Want to do all that in one go. That way, oops, I'm putting my semicolons in the wrong place. Doesn't really matter in this case, but put them in the wrong place. I wanted to do all that in one go so that when it gets formatted, it's all done. Looking at their text, it's formatted much differently. So I didn't want to lose my placing. All right, so that's straightforward for now, I think. If neighbor walls is 2, so the one thing that I'm a little confused on. Oh, no, I'm not confused anymore. Never mind. Room X, I was thinking of the center of the rooms. No. X1 and Y1, those are the corners of the rooms, of course. So X1 and Y1. X1 and Y1 is the upper left corner right here. X2 and Y2 is the bottom right corner right here. So X1, Y2 is the bottom left. X2, Y1 is the upper right. So that's where we get all these values from. So we give those But I guess it's possible that things have intersected and it's no longer an actual corner, so we don't want to do anything to it. I'm thinking that's the reasoning there. Yes, because other stuff might have happened. So that's all I can think of for that as to why we're doing that. Let's go ahead and test it, and then I'll come back and read the text concerning the algorithm. But I feel like it was pretty straightforward. A quick and easy one. We like that. Well, kind of quick and easy. Not the quickest. All right, let's take a look at these corners. Oh, yeah. Very nice, very simple. But it looks pretty cool, doesn't it? All right, so now that we've seen that, we won't be spoiling it when I scroll down. The code is we get all the rooms and panic if there aren't any. For each of the 4 corners of the room, we call a new function, fill if corner. Fill if corner counts each of the neighboring tiles to see if it's a wall. If there are exactly 2 walls, then this tile is eligible to become a corner. So we fill in a wall. You can try it out with the following random builder code, and we just did that, and we saw what it looked like. Part of me wonders if it would be worth implementing a trait to determine whether something is a room builder or a non-room builder or not. And you could do a little bit more enforcement on how you run these things, I think. I mean, right now we check, does it have rooms or not? And that seems like a little bit of a brute force way. Rather than asking, are you even a room builder? What was the initial builder, right? Was it even a room builder? But I guess maybe I'm just overthinking it. All right, decoupling rooms and corridors. There's a fair amount of shared code between binary space partitioning room placement and simple map room placement, but with different corridor decision making. What if we were to decouple the stages so the room algorithms decide where the rooms go, and another algorithm draws them, possibly changing how they're drawn, and a third algorithm places corridors? Our improved framework supports this with just a bit of algorithm tweaking. So we're going to look at simple map with the corridor code removed. So let me scooch on over there. Didn't expect to be touching simple map right now. All right, what do we have in here? Wait, did I click back to the browser a minute ago? I don't know, whether I did or not, it's fine. We'll click over for just a moment and make sure you can see they're running. I just read the text, though. It's not a big deal. Okay, so yeah, simple map. Let's take a look at it. Sometimes I just automatically push these buttons and I don't even think about it. And I'm like, wait a minute. Okay, so here we have horizontal and vertical tunnels still showing up. Apply room to map. Builder map, rect, initial map builder. We have the random number generator saying unused. It's because this has RLTK. It's fine. We'll worry about it later. Okay, so simple map builder, build map, self, RNG, build data. RNG and build data there. Okay, beautiful. Nothing special has changed there. So now, rooms and corridors is no longer what we're running. We're running something called build. Rooms, yeah. This is double checking. We're running something called build rooms. And we make our rooms here. We do all this. We can apply room to map. But then after that, we're not actually doing anything here. So that's it. WHXY, new room, yep. Mute OK. For other room, we said OK is false. If OK, we apply room to map. Boom. Yeah, that's it. What's going on, Tusk? Just woke up at 1 o'clock your time. Well, could be better, could be worse. Hope you're doing all right, man. Good to see you here. I still kind of want to do the other thing here. So we can take a look at it real quick. Rooms, we don't even need a 4. Rooms.iter dot all. And we're saying if any room intersects the new rooms, the new room, then it's false. So we'll say other room. I think I did this before. And then we need them all to be true. So we want to say not new room dot intersect other room. Actually, it was already there. And then that should do it. Unless I missed something. Oh, no, we do need the if, but yeah, there we go. So if rooms iter, and then we're saying all rooms must not intersect the new room. So the old code said, let's assume true, and then if a room intersects, we say false. And then at the end, if we're still true, then we can do this work. Here, I'm just saying all of them have to not intersect. It's, to me, nicer than making a variable that we're going to throw away, that, or not throw away, but that we're barely going to use. We have this nice construct in place to avoid that. Oh, whoops. Hold on. Oh, no, we're good. Tusk is here. Tusk was chatting. You still there, buddy? My stream manager on my phone says offline. The timer stopped at 57 minutes, 39 seconds, which was just about 30 seconds ago. My time in OBS, yeah, you're still here, cool. My time in OBS is 58:15. Weird. I looked at that, I was like, what is going on? The time's not moving. Okay, so we're good. Appreciate the confirmation there, dude. Okay, so we made my little change here as well. We should be good on that. So the let's go back to the text and just take a look at it. Other than renaming rooms and corridors to just build rooms, the only change is removing the dice roll to place corridors. So we'll make a new file called rooms corridors dogleg. What? Dogleg, I like it. I'm going to copy that name. And this is where we're going to place the corridors. So for now, it's going to be the same algorithm we just removed from Simple Map Builder. So I am going to take the liberty to copy that one since it's the same thing. And we're going to come in here and we're going to do mod that dogleg one. And this is one of those things where I could have literally copy pasted the code from the other one, I think. Well, there's some slight differences. But it's pretty simple. So let's read over it. Build map is the same as always. We're implementing meta map builder. That's cool. We're going to change this construct here. So instead of this, it's going to be rooms. We're going to remove the ref and we're going to clone. And we're going to do this right here. Shorten the code a little bit. We don't need this rooms anymore either. Shorten the code a lot a bit. And what are we doing here? We iterate over the rooms while we enumerate them. And oh, I'm stupid. I was like, where is I coming from? I thought we were doing a dice roll for some. No, we were doing the dice roll for the other thing. Yeah, now that I'm looking at it, we don't do a dice roll. Do we? Maybe we did. Yeah, no, we're doing one. Okay, I see it. Sorry, I'm looking at two different pieces of code, and it's throwing me off a little bit. And the text at the same time. I'm looking at like three different things at once, and sometimes it just crosses some wires. Okay, so we enumerate and iterate over the rooms. If I is greater than 0, so that should just be saying that it's not the first room, right? Could we not also just do skip? Not sure why we're doing it that way. I might make that change as well once we run it. But we get the new and the previous room's coordinates, the center coordinates, and then we do this range to decide whether we want to do a horizontal and then a vertical, or a vertical then a horizontal tunnel. And that's it. Very simple. So the text says, again, this is the code we just removed, but placed into a new builder by itself. So there's really nothing new. We can adjust random builder to test it out. Let's do that. And we're going to test that change that I wanted to make as well with skip. Oh yeah, dogleg corridors is not in there. So let's do it. That means we're probably going to add diagonal corridors or something as well. If we're doing one type of corridor, I could see us adding another type. So this should give us the same map we had before. Very simple. Oh no, we don't want to skip. I know why we're doing it. Hold on. Yeah, I know why we're doing this. I'm dumb. Forgive me. It's because we need 2 rooms. We don't want to skip the first room. I was thinking of like spawning or whatever. There is an option for this, but we can't do it here. We don't have use is not, no. So if you bring in the itertools crate, you can do something with an iterator that actually gets you windows. And so if we imagine having an a vector that, or an array or whatever, it's 1, 2, 3, 4, 5. We could do let my stuff equal that, just so it's not completely yelling at us. And then we could do my stuff dot iter dot I think it's windows, and then you give it the size of the windows, so you would say 2. And then what that would actually give you would be a tuple of 1 and 2, and then a tuple of 2 and 3, and then a tuple of 3 and 4, and then a tuple of 4 and 5. So I think that's called windows. I think that's it. So with itertools, we could actually do that without having to enumerate them and do that conditional there. We would just have the 2 rooms that we actually need. And it's a great crate. I'm not going to add it in just to do one loop here, just to modify one loop. But we could do that. That would be an option for us. And then you could say, you could literally just say room 1 and room 2, or new room and new and previous room or something. And that would be kind of nicer. It's arguable. There's nothing bad about this per se, but I'm just noting the existence of a crate that makes it really nice. So yeah, that's why we're doing that. I wasn't even paying attention to the fact that we were grabbing both rooms when I was stuck on why are we checking that? We could skip. We don't want to skip. Because of course we're drawing a corridor. We want a corridor from the starting room. So you don't get ahead of yourself, right? Alrighty. I'm guessing we might do diagonal corridors or something, because we specifically made something called dogleg corridors. It'd be cool to see different kinds, right? Same again, but with BSP dungeons. So we'll trim the corridor code, trim out the corridor code, and we'll just include the build function here. So let's go take a look at BSP. BSP dungeon, actually. It is much, much shorter now. We don't need corridors. I don't think we even need to sort anymore because we were sorting. Yeah, we're going to be saving that for later. I just looked over at the text. I'm like, we do still want to sort for a reason, and I'll talk about that reason myself. So let's break this down. Let meet rooms, clear rects, push, first room. Bring that down. All right, first room, add subrects up to 240 times, end rooms, while in rooms is less than 240, rect candidate. Yeah, that's it, if self is possible, end rooms, beautiful, very beautiful. So we're gonna move our BSP corridor code into a new builder without the room sorting. We'll be touching on that in the next heading, which is interesting. I think what we might do is we might make it where it sometimes sorts, sometimes doesn't. So we'll see. We're going to need rooms, corridor, BSP in map builders. So new file. And let's go ahead and add this in here. Now there's one thing I'm interested in here is if we're not sorting, what makes this different than the dogleg corridors that we just built? We want to be able to apply those corridors to multiple maps. Otherwise, there's no point in removing it from the algorithm, right? If you're moving it out and making it generic where it can be used in multiple places, you should be able to do that. So what's special about this? Let's find out. Something has to be special about it, right? So what we're looking for here in BSP corridors is a corridors function. And it's going to take in the usual stuff we've been passing around all this time anyway, so no big deal. Let rooms, vec, rect. I'm going to type this myself. Let some rooms equal build data.rooms.clone else. And I'm lazy, so I'm going to copy this panic. BSP corridors require a builder with room structures. And we're going to loop over the rooms and let room equal rooms I. Let next room equal rooms I plus 1. So we're just getting this room and the next room, slightly different than last, so we already have some differences. Let start x equal room.x1 plus rng.roll dice 1 I32 absolute value room.x1 minus room.x2. -1 on all of that. And same for start Y. All right, so we get the left side for X, we get the left side of the room with X1, and then we pick a random part in the middle of the room. So we go somewhere between 1 and the middle of the room, I guess, right? No, the end of the room, yeah. So it could go, if the room is 10 tiles wide, you could go 7 tiles over, right? Something like that. Or you could go 3 tiles over or whatever. We're picking a random X value within the room. And we do the same for the Y value. And then we're going to get some end values. And these come from the next room. And they're basically the same thing. So I'm going to copy those for brevity. They're the same things, but they're from next room, right? Next room dot X1. And we do the same dice roll on next room for the X and Y value. So now we have a start and an end for our X and Y, and we're going to draw that corridor. Start X, start X, start Y, end X, end Y. Very easy. So we go to the dog leg, and we're building these tunnels, right? But this is actually using the draw corridor function, which just goes over and up. It's kind of similar to the tunnel in a way. Let's see, let's look at how vertical tunnel works. For I, so I goes from the min to the max, with Y1 to Y2, whichever one is smaller to the larger. And it gets the index for each, and it converts them all into floors. For this draw corridor, we kind of always start with X. I remember this from before. We actually start with X, and we move until our X values line up, and then we move until our Y values line up. And it's interesting how we do that, because this while loop waits for X and Y to equal the X and X2 and Y2 values, the target values. And then the first thing we check is X. If X is less than what it needs to be, increase it. If it's greater than what it needs to be, decrease it. But these are else ifs. So only one of these is going to happen per each iteration. So we're naturally going to loop through until X is in position. Then we're going to loop through until Y is in position. So that's how all corridors are going to be drawn that way. So that is a big difference in the way that these are being implemented. Whereas before, with the tunnels, we said do one and then do the other, but it's kind of still the same thing happening with the way that ultimately these are going to end up just linking between, what's a better way to say it? Unless I'm missing something, this is still doing the same kind of code or the same kind of functionality that this here is. It's just a very different way of writing it, and draw corridor is always going to run in the same order, X and then Y. So I find that interesting. That we have kind of two different ways of doing it, and we'll see any other justifications for it. Okay. So the text says, again, this is the corridor code from BSP Dungeon Builder, just fit it into its own builder stage. You can prove that it works by modifying random builder once again. So we're going to, oh yeah, I left that let rooms there from when I copied it. Or no, I typed it, and then I'm like, I'm gonna do this thing my way, and I left that by mistake. So we're gonna come in here. I'm gonna try something as well to experiment. So we have the BSP Dungeon Builder, we have BSP Corridors. It just operates on rooms. That tells me that there's no reason I can't run this on a simple map builder. But I see nothing about that corridor code that is uniquely binary space partitioning. So let's replace BSP with simple map builder. And let's see it work. Yeah, just like that. We could also do BSP Dungeon Builder, and we can do dogleg corridors on it. I see no reason we shouldn't be able to. We're not sorting the rooms here, so this could lead to some very bad corridors. This actually ended up looking okay, though. Okay, let's change this back to BSP corridors and go back to our tutorial text. And we get this. So the sorting, yeah, was a thing that we did for a reason, and we're seeing the problem here. That's why I commented, like, it's interesting that we're removing the sorting. So what was, without even reading it, what was the purpose of the sorting? I would, ask to try and recall that. I do recall we were sorting by, well, I'll give just a moment more to think about it, or you could pause the video on YouTube or whatever. But let's try to understand why we were sorting the rooms and how we were sorting them. We were sorting them by their position. I believe it was their X value, just kind of a little arbitrarily. You could have maybe done Y value as well. But we were sorting, well, I think because the BSP corridors always goes with X first, it probably makes sense to sort by the X value. But anyway, we were sorting by their like positions, and then we were drawing corridors on that sorted list of rooms. And the reason for that is because we're not drawing tunnels all the way across the map, right? Then we're drawing tunnels between the nearest rooms to each other. That's the reason for it. So we'll read here. It looks like it works, but if you pay close attention, you'll see why we sorted the rooms in the original algorithm. There's lots of overlap between rooms and corridors don't trend towards the shortest path. This was deliberate. We need to make a room sorter builder to give us some more map building options. Okay. So, room sorter. I didn't expect to build one of these, but I think I get why. We'll see if it's used, like, as long as it's used in more than one place. If it's only ever used in one place, I kind of disagree with making the sorter. But maybe the other idea is this just opens us up to be able to implement more things. And so it's like, these are ideas, right, of different things that we can kind of modularly implement. Maybe that's the entire purpose of the lesson, which we kind of heard at the beginning. So room sorter is very, very simple. What I just copied is the boilerplate that's almost the same on every section now, except this is the bulk of the code now. I just had to implement the bones of this, and it's pretty much done now. Except this is going to be mute self for sorter, and now we're just going to actually sort the data. So build data.rooms.asmute.unwrap .sort by, and we're going to get A and B, and A.x1.compare and B.x1. And that's it. That's literally it. We're just doing the sorting code we had before, but we're doing it in this kind of modular thing that we can apply to any map. We do have a panic state in here if there are no rooms. Calling as mute on the option type will panic So that is a thing. And the text says this is exactly the same sorting as we had before. And we can test it by putting it into our builder. So let's go down here and do just that. Oh, yeah, we got to pull that in. I keep not doing the use everything, so we're getting the imports instead. There we go. A lot less overlap, but it looks pretty good still. We could also apply that to the simple map builder as well. In fact, you could apply either set of corridors to the simple map builder, or either you could sort either type because they both have rooms. And then either type of corridors you build would probably be a bit different based on whether or not it is sorted. You see what I'm trying to say? Okay. So, that's better. We've restored the look and feel of our BSP dungeon builder. More room sorting options. Breaking the sorter into its own step is only really useful if we're going to come up with some different ways to sort the rooms. And that's kind of what I was saying. Unless we're applying it in multiple places or changing the logic. I didn't mention that part. But this is the other case where we would want to break it out, is to have different options. We're just currently sorting by the leftmost entry, giving a map that gradually works its way east but jumps around. We'll add an enum to give us more sorting options. So let's go back into the room sorter. And up here at the top, room sort, leftmost. And we're going to go ahead and add rightmost as well, because it's showing up later. The starting section of the tutorial only included leftmost, but I'm going to go ahead and just preempt it by adding rightmost as well. So then room sorter now takes sort by. I was a little thrown off by that because that's also the name of the function that we're going to be using. Sorry, it's on the screen down there, the very last line of code, sort by. So that threw me off for a moment. Sort by room sort, and in room sorter, in our new function, we're going to have sort by there, and here it's going to be sort by room sort. Sort is a word that has now lost all meaning the more I've said it. Okay, and now everything is technically valid, but we're not using it, right? So what we want to do here is, we'll do it here. Match self.sort by, and we have leftmost and rightmost. And I think that should be, yeah, a.x1.compare b.x1. So then the text says, simple enough, we store the sorting algorithm we wish to use in the structure and match on it when it comes time to execute. Now we'll add rightmost, which will simply reverse the sort. So it's the same thing, except we do B and then A. We just switch which one we're comparing and switch the order we're comparing them. So that's so simple, it's basically cheating, says the text. Let's add topmost and bottommost as well for completeness of this type of sort. I think I just mentioned those two as other options as well, as we were talking about things earlier. So for these, it's going to be the same thing, but instead of X, it's going to be Y, right? So the first one for topmost is going to be y1 and then y2. So y1. Oh no, y1 and y1. Excuse me. I was like, wait a minute. Why would you do that twice? Stop it. There we go. And in these, wait a minute. I did make a mistake. Because we're going from the right, we do want these to be 2s. When we're going from the left, we want the left side of the room with x1. We're going from the right, we want the right side of the room with x2. And that's also going to apply on these. When we do bottommost sorting, we want y2 on both of them. It would still mostly work, but this is better. I'd say draw a picture or something and look at it to really verify why if you don't follow. But I think it makes sense. When we're going from the right of the screen, you want to look at the right-hand side of a room. And that's what you want to compare. Rather than the left side of the first room to the right or, you know, whatever. All right, so we've got topmost and bottommost added. And we can test them. We also need to actually like pass that in. So we can sort by bottommost. We could do that. I don't want room sorter here. I'm going to import room sort the type. So it's a little less verbose. And we're going to run it with the bottommost sorting now. Kind of like that. It's pretty cool, actually. Worked out. Alrighty. So we are moving right along. Back at the text, we can see bottommost in action. That's why I went with it. So see how that changes the character of the map without really changing the structure? It's amazing what you can do with little tweaks. We'll add another sort, central. This time we're sorting by distance from the map center. Okay. That's a big old beefy boy, but it's not going to be that bad. Room sorter. Central. And we're going to need a new match arm. And like I said, this is a big old beefy boy now. Let map center equal RLTK point new. So it's going to be the width over 2 and the height over 2. Should be okay. So we're defining a function. We're basically making this closure and assigning it to a variable center sort. Let a center equal a dot center. Let a center point equal RLTK point new a center dot o a center dot 1. And we're gonna do the same for B. Okay, so that's all good. Rect is not in here apparently. What? What do you mean no field? What in the world are you talking about? Let's give it a moment. Let me finish writing this and I'll debug those. If I even need to. So we have built-in distance algorithms already. Not Pythagoras squared, just Pythagoras. Distance 2D. From a center point to map center. Distance alg Pythagoras dot distance 2D. And it's going to be B center point to map center. All right, so we're getting an ordering back. And now we're going to use this function. All right, so there are two ways. Okay, mismatch in, let me close this, is going to help. Oh, did I, just a moment. Yeah, we're not, found closure signature. Okay, see, this one's a little beefy, but the difference is expected rect, but it found RLTK rect. And I think that explains everything. Can I just get rect from here? Yeah, that fixes everything. So I imported the wrong rect earlier. And what do you mean B? Oh, I didn't get one of these B's. Okay, good. All right, so that was kind of yelling at me for the whole time, but it's easy to fix. Wrong rect. That's why I didn't have the .0 and .1 here, but we now have that handled. It gives us a rect. Yeah. Or no, it's from rect. It gives us a tuple. There we are. Okay. So all we do is we get, well, it's interesting that we're using the closure this way. We could grab this from these braces here and go all the way down to this, cut that and put that here in place of center sort. We actually defined it and saved it to a variable, and we pass in the variable here. It's the exact same thing. Whatever you like more, doesn't really matter. But we've defined the center sort, which takes in two rectangles, A and B. We get the center of each and we convert them into points, and we use a distance algorithm to get the distance of A to the center and the distance of B to the center. And then we actually compare A to B, and that's our ordering. So we use that as our sorting algorithm. So now, are we just going to run it? Are we, yeah, we're going to run it. There we go. Let's run it one more time. it should almost spiral out. I wasn't watching closely enough. Spiral, not so much, but it should obviously be from the ones closest to the center furthest out. Yeah, it actually is spiraling quite a bit. Not so much anymore. All right, it's pretty cool. Okay. On the tail end now of the session today, notice how all roads now lead to the middle for a very connected map. We're going to clean up our random builder. Now that we're getting towards the end of the section, not there yet, let's take the time to really take advantage of what we've built so far. We're going to completely restructure the way we're selecting a random build pattern. Room-based spawning isn't as embarrassingly predictable as it used to be, so let's make a function that exposes all the room variety we've built so far. All right. It's a lot. Do I really want to write it? It's so much boilerplate. All right, we're gonna go through it. We will. Random room builder is what we have. Random room builder. I just wanted to get that copied so I didn't have to scroll over in the text. We're gonna do a roll dice, a 1d3. We're going to do simple map builder. And then we're going to have 2 and 3. 2 is going to be BSP dungeon builder. And this is going to be BSP interior builder. Okay, so we got those 3 in place. BSP interior still makes holes in the walls. So if it's not 3, if it's not BSP interior, now this is where I have a little bit of issue with it, because if you change it, you have to make sure you don't miss this number. It's 2 things to keep track of, basically. I have a little bit of a problem with that. So if it's not a BSP interior, sort by one of the 5 available algorithms. And we'll match on sort roll. And I'm not typing these. Let's be honest. 1, 2, 3, 4, and underscore, and then just left, right, top, bottom, central. Nothing special about that. Same thing for corridor and modifier roll. Very boilerplatey. Let corridor roll equal RNG roll dice. 1, 2. If it's a 1, we do dogleg. If it's 2, you do BSP corridors. Same thing for modifier roll with room exploder and room corner rounder. Now that we're done with all that, we have a start roll. Let's start roll equal RNG.roll dice. 1, 2. Match start roll. We'll do room-based starting position, or start X, start Y is random start position with the RNG. Builder.width. Area starting position. I will use start X and Y. Now we don't have random start, so we're going to build that in a few minutes. Where is it though? For the letter, call random start position to pick. Did we make that somewhere? No, we're gonna have to make it, but it didn't show how to make it. I mean, I guess we just want to roll between the map coordinates, so that's probably what I'll do. That's how I'll implement it. Just making sure it wasn't somewhere else and I'm forgetting. All right, so we're gonna get an exit roll. So we're gonna have that room-based stairs, or distant exit. And finally, we do a spawn roll, which I don't really need to type out. It's the same thing. Room-based or Voronoi spawning. And that actually does work in rooms. There's no reason it wouldn't. So let's generate a random start position. Oh, I see. Yeah. So let start X, and it's going to be a 1d3. And it's going to be match start X. One. We'll do left. 2. I forgot that we were using these here. And we're gonna do the same thing for Y. So and it's going to be start X and start Y. No? Oh, I should actually return, yeah. We'll just, shadow. We no longer need the roll. And we'll do that here. Yeah, we no longer need the roll after the match, so we'll just reuse the name because I'm being really lazy right now. So, what do you mean never used? Oh, it's never used because this is never used yet. Of course, that's why. All right. So there's a lot going on there. It's a big function, but it's pretty easy, so we'll step through it. Just really spreads out and it's full of branches, that's why. So we roll a 1d3 and pick from BSP Interior Simple and BSP Dungeon Map Builders. If we didn't pick a BSP Interior, which does a lot of stuff itself, then we'll randomly pick a room sorting algorithm. We'll randomly pick one of the 2 corridor algorithms we now have, and we'll randomly pick or ignore a room exploder or corner rounder. We randomly choose between a room-based starting position and an area-based starting position. For the latter, call random start position to pick between 3 x-axis and 3 y-axis starting positions to favor. We randomly choose between a room-based stairs placement and a most distant from the start exit. We randomly choose between Voronoi area spawning and room-based spawning. So that function's all about rolling dice and making a map. It's a lot of combinations, even ignoring the thousands of possible layouts that can come from each starting builder. There are 2 starting rooms with options, times 5 sort, times 2 corridor, times 3 modifier is 60 basic room options. Then plus 1 for BSP interior dungeons is 61. Times 2 starting position options is 122. Times 2 exit placements is 244 room options. And times 2 spawn options is 488 room options. So this function is offering 488 possible builder combinations. And now we'll create a function for the non-room spawners. I'm going to do that in a minute. I need to step away for just a couple of minutes. I'll put some music on and I'll be right back. My apologies. Right at the end, I know, but I'll be right back. Alrighty, my apologies again. I don't know what happened as I was just reading that last section. I just felt sick, nauseous. I don't know. I just needed to take a minute. I should be good to make it through the rest. I mean, I'm feeling better. Nothing happened. I just needed to like move around and stuff for a minute and have some water. Anyway, yeah, my apologies. Right at the end too, I was like, let's try to get through this. No, I'm not going to. I need to move. Okay, so the function's offering 488 possible builder combinations. Now we'll create a function for non-room spawners. And I'm not gonna do this. I'm just gonna be honest. This is boilerplate that, you know, we could do on our own. I don't think it really adds anything much at this point to type these out manually. It's a dice roll with a bunch of match arms, 1 through 14. Why are we rolling a 16? I think it's because we were rolling a 16 before, and now we no longer need it. I'm gonna make the call and say 14, and then unless the text specifies otherwise, I'm going to keep it that way. I think it might be a typo in the text. So we do cellular, we do all the Drunkard's Walk, we do maze, we do DLA. We don't have the heavy whatever that we did earlier. So we might apply that. Or no, these are start with. These are initial. Yeah, so that's fine. Then we set the start to the center and call. Easy. Set the start to a random starting area. Okay, it's an interesting approach. We set up and exit and spawn mobs. All right. Sorry, it took so long. I'm just processing and conferring with the tutorial as well to make sure there wasn't another typo. But yeah, we do see this 1d16, and we see it stops at 14. So I find that a bit odd. And all that's just what I read. It says it's similar to what we've done before, but with a twist. We now place the player centrally, cull unreachable areas, and then place the player in a random location. It's likely that the middle of a generated map is quite connected. So this gets rid of dead space and minimizes the likelihood of starting in an orphaned section and culling the map down to just a few tiles. This also provides a lot of combinations, but not quite as many. 14 basic room options with 1 times 1 spawn option times 1 exit option times 6 starting options with 84 options total. So this function offers 84 room builder combinations. So finally we put it all together in random builder. So random builder, we get a new builder, we do a type roll, which just sets up what our like initial map is, right? I still don't see us using that other thing we built before with DLA. Maybe we're just not going to use it now. Maybe it was an example, or we'll see it come back up later. Because we built that other version of DLA, no, it was DLA. That's the only one we built a new version for, right? Yeah, heavy erosion. I don't see us using that anywhere. Let's go back and look at it one time. Yeah. I mean, I guess it's okay, but you know, we kind of put it in there and then we're not using it now. Okay, so back to this. We get our initial map, and then whether it's a random room builder or a shape builder, we then do a random roll to figure out if we want to do wave function collapse on it. We then do a roll to find out if we want to add the fort, and then we add vaults. So the text says as much. This is relatively straightforward. We randomly pick either a room or a shape builder as defined above. There's a 1 in 3 chance that we'll then run a wave function collapse on it, and a 1 in 20 chance that we'll add a sectional to it. Finally, we try to spawn any vaults we might want to use. So how does our total combination explosion or combinatorial explosion look? Pretty good at this point. 488 possible room builders plus 84 possible shape builders equals 572 builder combinations. We might run wave function collapse, giving another 2 options. So times 2 is 1,144. And we might add a sectional, getting us up to 2,288. So we now have 2,288 possible builder combinations, just from the last few chapters. Combine that with a random seed, and it's an increasingly unlikely that a player will see the exact same combination of maps on a run twice. And that's it. That's the end of the chapter. Let's see. Well, actually, we'll go ahead and just peek at the next chapter before I go back to the code. Improved room building is next. So we're going to have rectangle rooms, circular rooms, cool, different shapes. This is going to be a really fast one. In fact, very fast. So what comes after that? Better corridors. We might try to do the corridors and the rooms next time. Dude, when I drag this bar, it doesn't work. It stops dragging. What is up with... So I do that, it stops, and then I scroll and it works. So goofy. I'll see about that. We'll figure it out next time, though. Improved room building is definitely next, and maybe also better corridors, because this one looks pretty short. All right, so back to the code and stuff, and let's run it a couple of times while I give an outro. Again, apologies for the break right there before the end, but I really needed to step away. Thank you to anyone who showed up, whether you are lurking or chatting. I appreciate it. If you are new and you like coding, or you like all the different kinds of games that I play, I recently finished Star Ocean: The Divine Force. I'm currently doing Dwarf Fortress, Caves of Cud. I'm about to start up a new game on Saturday. I play Genshin Impact every Sunday. I do play a wide variety of games. You can follow here on Twitch and see why we're getting these maps over and over. Give me something different. Okay, did I break something? Hang on. Just double checking. It is a 1d2. I hit save again. I think something might not have saved. I think that was it. Okay. Sorry about that. You can follow if you're interested in any of that stuff. You can leave the notifications on to see when I go live here on Twitch. You can also head on over to YouTube, where these streams go live 2 weeks after they're here live on Twitch. Or if you're watching this in the future on YouTube, congrats on being in the future. I would definitely appreciate if you would do all the fun YouTube stuff, like, subscribe, notification bell. You know how it works, right? You leave a comment. I do read and respond to comments. So there's that. You can also follow me on Twitter if you want to see when I go live. I've had people in the past complain that Twitch notifications are unreliable for them, that they would get them an hour or so after I started. And if you have a problem with that, or you're concerned with that, and you really, really want to know when I go live, then follow me on Twitter and leave the notifications on. And this is a goofy map. But follow me on Twitter and leave the notifications on, and we will you'll be able to see when I go live. I tweet every time I go live, and I don't do much else than that. I mean, I interact with a few things, but I don't do a lot else than that. So okay, wait. I see something. I will go back to that in a moment. But I just think I realized something. All right, that was my outro. It's a little scattered right now. Random initial builder is no longer being used. Yeah, there's the room exploder. Okay. I was like, we hadn't seen one of those in a minute. I was like, where was that getting applied again? Dude, there's so many places things are getting applied. That's why I was a bit scattered. I was like stuck on that mentally. Um, let's run one more. Bad outro today. I apologize. But it is what it is, okay? There we go. Still fun. Decent session. More refactoring, but it also added more functionality at the same time. Let's see what we get today on the BSP interior. God, I still remember when that was one of the first algorithms we did. It's been a while, huh? We're gonna collapse it. Yep. It's always a fun one to collapse. Alrighty. So again, that will be the end of this session. Next time we'll be looking at better rooms and maybe corridors as well. So with that out of the way, I'm out of here. Until next time, have a good day, have a good night, whatever it is, wherever you're at. Take it easy. Also, Tusk, yeah, that was a couple days ago, what you mentioned there a moment ago. I don't think it's the active one, though. I think it was an old one.
NANI?!